Hey class, so today's video is going to deal with the last section of 7.2, which deals with finding functions given an image and some points of a sine or cosine function. And that's where I'm going to start right here with this example. So as you can see over here, we have 3 points in this graph. Sorry, for some reason the tool isn't working. Here we go. So yeah, we have 3 points right here. We have 0, 1, we have pi over 3, negative 3, and we have 2 pi over 3, 1. And just given these 3 points, we're not really told where it starts. We're not really told anything else about this graph. We can actually try to find some function that describes it. And if we look to our right, we see a list of 5 different functions. So if you want, I'd like for you to pause the video right now to see if you can spot any of these that actually solve for this function, create this graph. So if you've paused the video and thought about it, hopefully what you found was that all 5 of these solutions give you this graph. And if you didn't pause the video, let me try to explain how that is. So all we know about this graph is that it crosses these 3 points. We're not told that it starts at 0, 1, so technically we could have a graph that starts here, or we could have a graph that starts here, similar to here, here, or here. And basically that's what all of these functions do. They start at different points along this cosine or sine function, and basically travel along until they hit those 3 points. So this first one right here, you'll notice that it doesn't have a vertical shift. It doesn't have a C over B. Sorry, not a vertical shift, a phase shift. So that's C over B, right? Hold on. I don't know why it's highlighting like that, but anyway. Since it doesn't have a C over B, this graph would actually start right here. And since it's starting from a positive direction, that would mean it's a cosine function, right? But if we look over here at this second function, this is a sine function. But it has a B or C over B, which means it's shifted to the left. And in fact, for this one, we'd start somewhere either here or here. I think it would start here because it's negative pi over 2. So it's like halfway between this and this, so like here, right? And this actually has a vertical shift of negative 1. So that makes sense. It starts right about here. But anyway, my point is that when you're just given the graph, you can find any number of solutions. There might actually be a limit on this. It could be infinite. Actually not sure. If I had to guess, it'd be infinite. But not sure of that. Any number of solutions. So that means that we need to introduce, we need restrictions or assumptions. Either way you want to look at it. So we need to restrict what we can do given any kind of graph, or we need to kind of limit the number of solutions that we can get. So the first thing that you're going to see when you get a problem like this is it's going to have either a cosine or sine function. So it's going to say I want a cosine bx minus c plus d. We want this, right? The second thing that they're going to do is they're only going to show you the first 5 quarter points. So up here, like I said, this first one started up here, whereas the second solution started down here, right? So when you're given these types of problems, it'll tell you exactly where you started. So if it told you started up here, that would mean it'd have to be a cosine function, right? So second, only 5 quarter points. So you're only given those 5. So I think that's enough build up. I think we can just go into an example and maybe walk through that now. So Okay, so here we see that we have a cosine function, and this cosine function has 5 quarter points. The first one being here, the second or the last one being here. And the first way I like to approach this, there are many ways you can approach this, but the first thing I like to do is try to find both the amplitude and the periods from these quarter points. So the first thing that we can do is find the amplitude by taking the minimum and the maximum and finding the distance between them. So the way you would find this distance is you take the maximum and you subtract the minimum. After this, you divide by 2. Because remember, the amplitude is the measure between it's like the halfway point between the maximum and minimum of your cosine functions and sine functions. So this will give you 2. And even though I said this was the amplitude, which I guess it kind of is because it's always going to be positive, um, but we also need to put a sign in front of this too. So right off the bat, we know it's a cosine function and it's starting at its minimum. So that means this a is going to have a negative in front of it. So we're going to have a -2 for a. So -2 cosine, and then bx minus c plus d. So like I said, the second thing I like to do is find the period. So remember, the period is the distance between the first point and the last point as far as the x coordinates go. Right? The amplitude was from the y coordinates, the period is from the x coordinates. And we do the same exact thing. We take the maximum and subtract the minimum. So this means that we take, to get the period, we take pi over 3 and we subtract a negative pi over 3. So that gives us 2 pi over 3. So remember that the period, or maybe I should say b, is 2 pi divided by the period, right? The period is found by taking 2 pi and dividing it by b. So hopefully you can see right now that our b is going to be equal to 3. So that's going to be 3x. Our c is going to come from our phase shift right here, this first x coordinate, because remember c over b is equal to our first x coordinate, so c over b is negative pi over 3. And since we just found 3 by getting our period, we can plug 3 into b. And this tells us that since c over 3 is equal to negative pi over 3, that c is equal to negative pi. So now we have minus pi. And the last thing we need to know is d. And for d, all we have to do is look at these points right here. And this is going to be, I put plus, but really that's going to be a -1. Now there are many ways you could have found d here. That's kind of the hard thing about teaching this. Because really you can look at the middle points of any sine and cosine function and look at its y coordinate, and that'll always be d. The only cautionary tale I have to that is that if you look at these points for your sine and cosine function, or sorry, for your sine function, right, you're no longer looking at the middle 2, you're looking at the middle 3. So these points, the y coordinate, will be your d. So you'll have some x coordinate, and then your y coordinate will be d for these 3 points. Yeah, there's other ways you can do it. I mean, you could take a, the absolute value of a, and you could add d, and that should give you 1. Since the absolute value of our a is 2, then we get this relationship for d. And again, this also gives us d is equal to -1. So, yeah, there's many things you can do. But that's the basics of how you solve problems like this. Up next, I'll just do a quick video on the tangent function, and that'll be everything. All right. See you then.